All right, so you have now seen 1/4 of my slide deck. I want to call that out because this is a technical talk and it's targeting a technical audience. I really, really hope that you enjoy code as much as I do. I really hope that you enjoy legacy code as much as I do. And those of you who want to spend more of a talk leaning back and seeing something in PowerPoint, there are 4 wonderful options to go explore. Those of you who want to spend more time in an IDE and wrangling with some interesting stuff, welcome. So, I'm going to be talking about refactoring to some asynchronous patterns. But before I get into that, I first have to clear up one word of the title. And it's not async. The word is refactoring. The problem is everybody thinks it means a different thing. So in order to talk about that, I'm going to pick some code. So this is a very simple piece of code. You can see here the top half of the function. I'll scroll down and you'll be able to see the bottom half too. And the first several examples that we're going to work with this code. So just a chance to get some familiarity with it before we start looking. And the bottom half finishes off the switch and the loop. Okay? So it's a very simple little function. Now, I like to work with legacy code. That's really my joy. I'm hoping that at the end of this, you will also like working with legacy code. This is my attempt to make something that is as evocative as possible towards legacy code while still generally fitting on one screen. So pretend it's like this, but that switch statement is 500 lines long and has non-local go-tos. And then we're really talking about where we like to play. So while we will be working with interesting code later, this is interesting enough to talk about the first bit, which is what is a refactoring? So I've done several. This first thing, come on, keystroke work. Ah, there it is. So the question is this a refactoring? So what I've done here, there was the old code, which was this for loop with a switch statement in it. And this new code, I have done what my commit comments claim as a refactoring. All of these are claimed as refactorings. And this is even known as replace algorithm. It's on Fowler's list. I've replaced the loop with a switch statement with instead an algorithm where I count the number of votes, and then at the end I see whether the number of positive votes exceeded the number of negative votes, and I say that was a success. Okay? So this code is trying to figure out whether a proposal should be accepted. Okay? People vote for it by majority. So the question is this a refactoring? Who thinks this is a refactoring? Okay? Who thinks this is not a refactoring? Okay? Can someone who is relatively close to the front give me a reason why this is a refactoring? Why they think it is? It does basically the same thing. Yeah? In fact, this code, there's no test over it, but that's normal. This is legacy code. But this code does behave exactly identical for all legal inputs. Okay? So who thinks this is not a refactoring? And can give a reason why. Yeah?
It's not a transformation?
It's not a transformation. That's interesting. Yeah. So how do you know it's not a transformation?
It's not a machine implementable.
It's not machine implementable. You're right, because there is one novel piece of this, which is that I switched from counting all the positives and negatives in a separate thing to summing them along the way, right? So it's not machine translatable. So yeah, I would say that's probably not what I would consider a refactoring. In fact, I definitely wouldn't consider it a refactoring. Let's go look at the next one. So now I'm going to do another attempt. But there's one other thing that makes that first one not be a refactoring. And that is, I said that it operates exactly the same for all legal inputs. What does it do for illegal inputs? Well, so let's look at one little difference here. I'm switching on an enum. What happens if I if I have an invalid value for that enum? Code on the left throws an exception. The code on the right ignores that vote. Right? So I have accidentally changed that behavior. Now, likely, that could be seen as a bug. If I get a bunch of votes and someone has given an invalid vote, my system on the left, the original one, crashed. My system on the right simply ignored that vote and carried on. Right? So I've accidentally fixed a bug, therefore it's not a refactoring. Let's look at the next one. So this is exactly the same with one additional difference. The AV Studio is opening a million of them. OK. That's not the one I want. So this is exactly the same, except the difference is right before the loop. Come on. There we are. Right before the loop, we do a check of the votes to see whether there were any that were neither an approve or deny. And if there were, where is it? So if not, it throws an exception. So the question is, since this is being painted and not showing up, is that one identical? There we are. There we are. There's the approve or deny. If we don't have an approve or deny, it throws an argument out of range exception. Is this one identical? No. All right? So why do people think this is not a refactoring? So abstain is still handled correctly. Yeah. Abstaining is handled correctly. And now an argument out of range is still thrown correctly. So again, it's not an automatic transformation, which is interesting. However, this code does behave exactly identical for all current inputs. So is it a refactoring? Well, I still argue that it isn't, because there's a class of inputs that it behaves differently on, and that class is future edits by a programmer. In the code on the left, if I add a new value to the enum, then I'm going to get one set of change in behavior, whereas in the code on the right, if I add a new value to the enum, I will get a different change in behavior. The code on the right will throw an argument out of range exception. The code on the left will ignore that value, I believe. Anyway, it'll give slightly different behavior. So in that sense, while it operates exactly identically today, future developers are going to do different things with the two pieces of code. And so when I'm working with legacy code, my goal is bug-for-bug compatibility. And I hold that to a really, really high standard. There was a time when I was working at Microsoft. I was working in OData, working on the OData standard there. And we defined a standard in a way that made obvious sense for some little portion of the language. I've forgotten which one it was. Life was going good until the Entity Framework team said, I think there's something here, you should go talk to the SQL team. And we talked to them, and we talked eventually down to some PMs who really knew SQL deeply. And they said, yeah, that's great. That specification is exactly what we should be doing. If you do that, we will not be able to follow the standard. And it would be bad for Microsoft to not follow the standard that they're publishing. So we asked why, and they said, because about 15 years ago, when Fox Pro 1 was written, there was a bug in it, where this part of the behavior didn't follow the SQL spec. And a large number of people took it on, including one major automotive manufacturer, and they produced a piece of code that is running nearly $1 billion of their business. And it's business-critical functionality. And about a decade ago, they lost the source code for it. Now, Visual Fox Pro was purchased eventually by Microsoft, and then it was used and incorporated eventually into SQL Server. And some of that technology is there. Much of it is not there anymore, but the users were brought across, including this company. Right? And this company pays Microsoft hundreds of millions of dollars every year to buy all sorts of different things. However, at one point, SQL Server tried to fix this bug. And were kindly told that if they did not leave that bug in there, it would take down $1 billion a year of automotive business, and we would be losing that revenue. Right? So there is now, it's on the list of bugs. There is a list of bugs that shall be preserved evermore. Right? Because it is critical for someone's business. So when we're refactoring, and I started really doing refactoring right while I was at Microsoft, we're going to be working with a function that is, say, 26,000 lines of code long, that's using non-local gotos to hop between, actually in that case, there were two functions, each 26,000 lines of code long, which were copy and paste from each other about 85% identical, and used non-local gotos to hop back and forth, and did assume that the stack layout was consistent between the two, although the operations were not. We're going to be refactoring that code, and we need to maintain all the bugs that were there, by the way, most of which are not on our list of known bugs that we're maintaining. We don't know it exists. So that's the level of the standard that I like to hold myself to when refactoring, is we need to prove that this code is bug for bug identical, that bugs that I don't know exist will still be there when I'm done, even though I don't understand the code that I'm working with. And that's why the recommendation up front about this isn't an automatable transformation is key. So let's talk about a simpler example. Is this one a refactoring? I hear a yes. What refactoring is this? Extract method. Yeah. I lied to you. This one is not a refactoring. However, this one is. Note, the two of these are character for character identical. What's the difference? How can two different code transformations that result in identical code, one of them be a refactoring and the other one is not? I see the gesture. Typed. Yes, I edited code. The difference is that in the first one, I can't prove it is bug for bug identical, and in the second one, I can. In the first one, I just got lucky. Actually, what I did was I did the second one first, and then I typed that code because I wanted to make sure that I could prove my point. But the thing is, in that first case, I got lucky. In the second case, I had a mechanism of proof. Right? And so that's the key thing on a refactoring, is that I've got some mechanism of proof. So what mechanisms of proof do I have? What are ways that people give evidence that their refactorings are good? What are some ideas that people have? Tools. Yeah. So I'm using resharper. I'd use resharper extract method. How safe is that? Very. Is it totally safe? No. Yeah. There are some known bugs in it. In fact, entertainingly, there is a known bug in it that was implemented, was fixed, and the community told them to unfix it. This bug exists in ReSharper. It also exists in Visual Studio and several others. If you do an extract function on a function which is using multiple threads to access the same variable, then that will work as long as you declare that the parameters are ref params, and then you will have the same behavior under all possible threading paths as you did before. Whereas if they are not, you can get aliasing problems. Right? So that's a class of bugs. They fixed it, and the response from the community was, you made my code look crappy. You've put ref params all over the place. Take them out. Right? So now the tools all create the wrong code, but it looks nice. Yeah. So bugs, we love them. In fact, we as an industry keep intentionally creating several of them. So the key thing with the tools, though, is I can identify whether I'm in one of those cases. And I can fix the ones that I choose to fix, and I can choose to not fix the ones that I choose not to fix. And then if everybody knows what all the bugs are, nominally I can tell whether I broke my code and whether I need to add refs or other things. Okay? Great. Can you extend the set of operations that ReSharper can do? You can. You can write plugins for it. Right? Can you fix the bugs in the existing refactorings? No, you really can't. Yeah. So there's another way to do a refactoring, which is to become a tool yourself. And I talked about these a lot at Deliver last week, so I'm not going to talk in great depth about it here. But you can use recipes. And I have a recipe here. This is a C++ implementation of extract method. And it has been debugged, right? And it's got a particular way of going through. And we'll actually, so we came up with this at Tableau. We debugged it for a while until we got to the point that the only bugs ever introduced by people while using this recipe were used by them, or caused by them taking shortcuts and not actually using the recipe. So we think it's solid. It is specific to C++. You can use it in any language that has a really good compiler with strong typing and supports lambdas. So that's C++ and TypeScript. Everyone else, well, you know, hope you got another good tool. But these are interesting because can you extend this definition? Can you fix a bug in it? Yeah. Yeah, we could put these up on GitHub, and then we could, as a community, improve those. So we're going to be doing that. And that makes this a very useful and interesting class of refactorings. But here, I wanted to talk about something a little different. And that is, OK, great. Single refactorings are wonderful and awesome, and we want to do really good, clean transformations. But I'm working with nasty, ugly code, and I want to make it look not nasty and ugly. Let's go back to a new example. So this is some code that I ripped out of another project that I'd been working on and then just cut off all of the extended bits. So if you look one layer under every one of these functions, it just throws a not implemented exception. So it's basically your typical legacy code. But it's an interesting example to work with here because it's a place where asynchrony would be really, really nice. It does, thank you, GitHub. It goes ahead and reads from a file. It does some file parsing. And then on the basis of that, it computes a bunch of values. Then it logs in to a couple of web services. Then it uses those makes multiple calls to those web services, updating a bunch of values. And then the values that it's updating, it's creating as view models, which it's going to display on the UI. So this code, in its original form, works. The only problem is you open a file and you get a little spinny thing for a while, right? And it could be for a really long while if you happen to be located in South Africa. So what I'd like to do is make this code async. Right? I'd like to be able to do all of those web requests in parallel. I'd like to do the parsing incrementally, start off some of the web requests while we're still finishing the parse. All of that stuff would be great. How do you feel about safely transforming this code while maintaining all bugs into an asynchronous program? I see the laughs in the front row of, I've tried that. Yeah. Okay, so not straightforward. So here's a recipe. That recipe is hard to read. So here's a recipe. Okay. In this case, I've already done step 1 for us. Normally, when I start with a set of code, it doesn't look nearly as tidy as that example that I gave us. It's just a whole bunch of inline mess, right? So the first thing is do a lot of extract methods and create a template method. Right? And it turns out the root of most refactoring, most redesign, the first thing you do is you make it readable. I teach a thing called read by refactoring, where I'm teaching people that the best way to read code is by refactoring it. Right? And that's another reason that I really care about the provability of these refactorings. Right? Because I need to make sure that when I'm reading code, I introduce no more bugs than the guy next to me does when he's reading code. It'd be really embarrassing if he reads code and no bugs happen, and I read codes and we have a site outage. So my way of reading code modifies the code. Therefore, I need to make sure that it never, ever, ever introduces a bug. But given that, then I can read code once, and then the next time I read code, it becomes a lot easier to read. And assume that my code is 26,000 lines long and has non-local go-tos and all of that mess. Will I ever be able to read that code and understand it? No way in hell, right? However, if the way that I read code is I look at the code, I get one insight, and I write it down by doing an extract method or a rename or in some way putting it into the code, then now I can look at the code, and that insight is immediately obvious in front of me, and I can start looking for the next one. Repeat iteratively. Now, will I ever be able to read and understand that code? Yeah. It might take me a while, but I will actually be able to understand it, which means when I make a change to it, in the first case, where I read code by reading it, what is the probability that I'm going to be able to make that change without unwanted side effects? 0. Yeah. In the second case, what is the probability I will be able to make that change without unwanted side effects? It's actually pretty decent. Yeah, it's still not 100% because we're talking about, at that point, editing code because I need to make it behave differently. And so there is a probability of error, but I can dramatically reduce my probability of error. Right? So the first part of most any refactoring, most any redesign is basically read the code. Read it by refactoring it. And for that, there's 6 refactorings you use over and over, extract method being the most common one. And that's what we're doing here. We turn that mess, we make it readable. Okay. The next thing is I sure would love to have the code under test. All right. While a lot of my refactorings are provably safe, it's going to be really, really hard to prove that that transformation from a synchronous dependency maintained by the program counter to an asynchronous dependency maintained by, we'll come back to that in a moment, is consistent. There is no tool out there that is replace go to next statement with task. Right? So I need to find something that will allow me to do that safely. Right? So the thing that I do is I lift code to data. And that's the second step. So what we're going to do is we're going to take the sequential nature of a program that it operates. The first thing I do is I load a character file from a file system and parse it. And the second thing I do is I load the config file that's relevant to that, and I parse it. Right? The thing of going from the first to the second, what I like to call the semicolon operator. I would like that semicolon to be something that I can inspect and demonstrate. Because while that semicolon is relatively straightforward, the semicolon at the end of this for each loop is not. Right? I want to prove that everything's still working. So, how do I do that? Well, that'll be this next step here. We're going to lift code into data. And we'll lift all of those sequence operations and make that actually be data that we can inspect and adapt in some way. Now, I won't be able to statically analyze that. I would love to find a way to statically analyze it, but I haven't yet. But I can at least lift it to something that I can runtime analyze. Okay. Now, the next thing after that, now I'm in a place to turn code to asynchronous. However, I still want to be paranoid. Right? So usually what people will do is they'll take the template method and they'll start throwing in tasks or the word async and try and get it working. The next thing that I'm going to do here is I'm going to take the sequential code that is all broken up and I've lifted to be where the sequence is following my data. And I'm just going to replace that sequencing operation from instead of being a synchronous call to be an asynchronous call that will be executed synchronously. Right? So there's no parallelism going on. All that I'm doing is taking on a performance penalty. Right? That's the entire value of my work so far. Right? However, when I do that, I will have now introduced all the asynchronicity primitives into my system so that now I'm ready to actually stop refactoring. Because the problem statement was to improve the performance of this thing by overlapping things, and that is not a refactoring. Overlapping I/O operations cannot be a refactoring. I'm changing the behavior of the program. Right? My goal is to refactor to the point where I can change that behavior in an easy way. Right? But I also don't want to fool myself into thinking that when I'm actually making the code behave the same but go faster, I'm in any way refactoring. Right? So, let's look at what we do. What are some ways that I can make visible, make verifiable, the semicolon operator? Anyone have any ideas? There are a couple of options. Put a method in between them. Interesting. Yeah? Yeah? So I could put some sort of a method call in between them, right? Where I do something, and then I say, one method call that's useful for this is a log statement. Right? So this is a common approach. I'll go ahead and put a bunch of log statements in a bunch of different places, and then I'll use some facility like approval tests to validate that my two logs are identical. And if I replaced every semicolon with, and I could do this automatically, every semicolon with a log statement that refers to its original location, then as I'm refactoring along, that could work. Okay? So that's one way to do it. And it does work. What's another one? What else could I replace a semicolon with? What else in a computing system, besides a method call, says, after you do this, do that? Well, let's take, in this sort of a code, you're probably not familiar with it, but what if I'm writing microservices? What was that? A promise. Yeah. Promise might be a way to do it. And if I'm writing a service, event bus is a really common way to do it. Right? I'll send a message to somebody. I might send a message to myself. Right? So events and messages are a really good replacement here. I can use that. And an interesting thing about a message or event of any sort is, how do I observe which ones are happening? Right? That's easily recordable and auditable. Okay? Now, a promise is also an interesting one. Because what's the difference between a synchronous promise and an asynchronous promise? There isn't one. Right? From the caller's perspective, they're identical, which means that will allow me to bridge that gap in step 3. right? If I have something that's a promise, then I can simply have it evaluate differently, and I moved from the synchronous world to the asynchronous world. That's awesome. Now, in my case, I'm wanting to do something that's an intermediate step. I actually do the step to the promise second. The first thing that I do is, and the reason for that is that some of this code is tidily functional and pure and promises work well. Some of it is not, right? So there are some code which is highly side effecting, and where an event happens and I want to push it forward and then cause something to happen in the response to that. Right? So I start with events, and that will allow me to transform the code into something that's identical without having to mess with all that stuff. And then while it's on events, I can switch some parts of the code that are functional to be tell, don't ask, or vice versa. And then I can introduce promises, and then we're off to the races. So let's look at the code, or how we did that. So another interesting thing, I want to do a small segue here. This is me doing that process. Looking at this history here, thank you. Right. Looking at this history here, how hard is it to code review this? So assume that you got this commit here as a commit. Your job is to code review it. Where did I make mistakes? Where do you want to look for? Well, let me just tell you a little hint. See that character on the left? If it's a capital F, that means that commit is an improvement in functionality. If it's a capital B, it means that commit is a bug fix. If it's a lowercase r, that means that commit is a refactoring that I used some static analysis to prove was safe. If it is a lowercase a, that means I used some automated tool to do something that doesn't change the code. So for example, I changed the white space settings on ReSharper and told it to reformat everything. Right? And if it's a lowercase t, it means that refactoring introduces additional testing but no changes in the code itself, just in the tests. Right? And if it's 3 exclamation points, it means it was none of those things. I was trying to refactor, but there's some reason that I don't think it was necessarily perfectly safe. So where do you look if you're code reviewing this code? Where are the places where I could have messed it up? So it's wherever I did 3 exclamation points or a capital letter. Like, those are the places where behavior could reasonably have changed. Right? And each one of these commits is very, very small. So this massive commit that is very dangerous is that big. That's the whole diff. Yeah. So I highly suggest that when you're working, you work in these tiny, tiny commits and check yourself on its level of risk, and then you do a final merge at the end to bring the whole movement together. There's a reason I don't squash commits if I'm going to submit to anything, right? Because if I squash the commit, how hard would it be to review this thing? I've changed everything. Every single line of code in this function that we're working with has changed across this movement. Good luck verifying that. Right? But if you see the pieces, you know, safe, 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 dangerous. Oh, that's good. Safe, 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 dangerous. Right? You can actually verify it. Saves a tremendous amount of time. Right? The other nice thing is, if I'm going through and I'm refactoring, I do some work, I go to commit. First letter of my commit message is one of these letters. What's that force me to do? It forces me to separate the commits, right? What else does it force me to do? Make them small, right? Forces me to keep them small. Anything else it forces me to do? Think about the category. Yeah, and that one's critical, right? Because often I will do what I think is a refactoring, and then I'll get here and I'll go, I would have to type 3 exclamation points. Is there any way that I could do this more safely? Right, and because they're small, what I'll do, my response to that will be revert. Right? So I'll revert immediately, and then I'll think about, okay, now I know where I'm going. How could I get there safely? And turn this from 1 commit with 3 exclamation points into 3 to 4 commits with little r's. Right? So that means that before the code ever gets to the code reviewer, it's already been a lot safer. Right? Everything is about not accidentally fixing bugs. So let's go look at some of these movements. So the first movement, I'm actually introducing this library. Now, I'm not going to go into too great a detail on this one, but I'll talk a little bit about what this library is. Thank you. So I actually had a copy of this library from a previous project, and then realized that somewhere in the vestiges of time, it vanished. So I had to re-implement the whole library. But that's OK. This is legacy code. That's common. So this library is fairly simple. It consists of basically a re-implementation of event. Right? But I want it to do one different thing. So event. Normally what event does is you expose one, people can subscribe to it, and then when the event is fired, they execute. Cool. The additional thing that I want to be able to do is to query it and ask, who's subscribed? Because then I can write an approval test that will go through the entire graph of events and say, what's subscribed where? What's the sequencing? And then write that out in a diagram. And in fact, if we go all the way up to the end, one of these, yeah. So all the way up at the end, this is what's output. Right? So we can actually see that there is a sequence of operations. Oh, that one's for a stupid test. Yeah. This was for the actual code. So this code is doing some sort of a config, loading a config file, then figuring out or loading the character file, then the collector that matches it, config file, and so on. And it's doing a bunch of these operations. But I have this as the output, the approved side of an approval test, and so I can verify that I don't ever change it except when I intend to. Okay. Awesome. How do we get there? Because I would like, and this is where it gets tricksy, I would like to be able to introduce this thing incrementally and in a safe way. So this change. Thank you. Okay. Clearly, I've made the code better. I took it from 1 line to 5. I do that a lot. So on the left, all that we do is we do the operation of loading a file, and then we do a semicolon. On the right, what we do is we set up a pipeline, pipeline being this event sequencing thing, and that will, at its first step, load the file, that character file from, and then we do a bunch of random shit. That stuff is semicolon. Because the challenge is, as soon as I put something in the pipeline, then now the operation has its effect in the pipeline, and the rest of my code, I don't want to put it all in the pipeline at once. I will make a mistake, so I need to get it back out. So I've created these collectors and traps so that I can put one thing in the pipeline, have it operate like that, then get all my data out, and then do the existing rest of the algorithm. Okay. So this is a change. Now, is that a refactoring? No, it is not a refactoring. It's marked with 3 exclamation points. Right? This needs to be done manually. However, I can make it close to a refactoring. Some parts of this are pretty near automatable. And in fact, what's happening is this part here, the character file from, without the argument, goes into the first line as what will be executed in the pipeline. All right, so I can paste in the template of the first line and then paste that into the place. All right? Then the stuff on the left, the variable, is the last line, which needs to map to getting the thing back out of the trap. And then everything that's in between is copy and paste code. It's boilerplate. All right? So it's not a refactoring, but it is a pretty safe boilerplate operation. So next thing, obviously, is to do the same thing again. Now, this one's not quite the same thing, because I could do it the same way, right? But I actually want to do something slightly differently. Now, I could do immediately after I did the first thing of put it in the pipeline and take it right back out. I could put the next step into its own pipeline and take it right back out. But the point of this is I want to go to asynchronicity. And to go to asynchronicity, I need to have the one thing depend upon the completion of the other. And that was the whole point of putting this pipeline in there. So I'm actually doing the second form, which is instead of creating your own new pipeline, take this thing and add it to the end of the prior pipeline so that it gets data through the pipeline. And then I still trap all of the intermediate outputs. Okay? And this is similarly not a refactoring, but you can make it simple and safe. Okay? And we continue in this in the obvious manner for a very long time. I'm not going to walk through every detail of this. But throughout the course of that time, we eventually get it to the point where we're starting to write some tests. So here is one of those. Let's look at that. Simple approval test. And I can check that it is doing all the right things. Okay. Simple test. It sets up the pipeline, and then it approves the result, right? Which is done by calling that toString and outputting the whole thing. Okay? And as a result of that, I get my approved side, which checks that I have set up the pipeline exactly as I wanted. Right? So the config file depends on the character file, and then I've got 2 traps in there to catch my outputs and carry on with life. Awesome. That'd be great. If only all data flowed through my system in a one-to-one manner. So I could carry on with this exactly as it is for exactly as far as I did. Going any further than that, the next thing that I want to do is, OK, great. In these character files, there are a bunch of things that are cards. Don't really know or need to know what those are. But there's a one-to-many mapping of file to thing that goes on screen. So I need to have a thing generate a whole bunch of different things, and that gets funny when I switch to events. I want to send a whole bunch of events. I want to have my pipeline respond correctly to that. Okay. So there's an extension to the pipeline that needs to happen. And because I needed to write this pipeline as I was going, I didn't actually write that at first. But now I needed it. And so I have this scatter. And I implemented it, and then I refactored a whole hell of a lot along the way. And you can sort of see how much of the code is adding features versus how much is refactoring, how much of the work is. But now, what I get is this scatter. And I want to reload. that. Okay. So at the top, it's creating some pipe. There we are. So that first chunk, the create pipeline, is the old thing that's creating the two files, and then it does some more stuff for the other parts where it's actually doing a scatter. Right? So scatter does fan out. Right? And then there's also fan in, and then the last one is delay. Wait until 2, 3 things have arrived, and then execute it accordingly. Now, I haven't written that part out in the example code here, but that happens in the obvious way. Right? So this code is now taking the first part of that for loop, and it's setting up to do the for loop. We can continue on in this way. It will get boring, so I'm not gonna. Right? But you can continue on in this way indefinitely until you complete the whole step of turning the code into data. Right. Now, this actually shows up in a whole bunch of places. Right? I'm going to stop here and not go into turning it to async. The rest of the steps are actually fairly obvious. Replace the event with a task or a promise, and it behaves exactly identical. Then have that promise execute in a asynchronous fashion, and it behaves identical because you've got the dependency structure to do the responsiveness, and then you can start coding away. Right? The tricksy bit is actually just lifting the semicolon, right, into data. So that's an interesting technique. Where else can it be used? So how many people write programs that consist of get some sort of data from somewhere, look at it a bunch, go get more data from more places, mash it all up, and then throw it somewhere? Pretty much everybody. Yeah, that accounts for 90% of the programs we write. Right? There are counterexamples, but data flow pipeline is one of those common meta things. Now, somewhere I might throw it. I might put it on a screen. I might put it on a database. I might put it to a log file. I might do all sorts of things, but I get a bunch of data from a number of different places, mash it together and look at it, and then toss it somewhere for somebody. So how would I verify that? How do I test that that code is doing the right thing? Well, so first thing, I wrote a bunch of unit tests so that when given these couple of pieces of data, I transform them correctly. Check. When I want to go fetch a thing, I ask for it in the right way. Well, that one gets a little risky. Like we're talking about a platform test, or ports and adapters and hexagonal architecture are the answer to that. Great. It's a solved problem, and you have to go learn about that, and you solve that problem. Awesome. Check. All right. Then, once I've tested all the various pieces, oh yeah, how do I verify that I put it out to the right thing? More ports and adapters. Right? Refactor to use MVVM, all these sorts of answers. Okay? So now I've got that last little problem, which is how do I ensure that I bound all the pieces correctly? Well, this is where most people say you write an end-to-end test. Okay. End-to-end test, great. Well, it's slow, but it's critical, right? Or is it? How much safety does a typical end-to-end test provide? A path. Yeah. Yeah. If I'm talking about a typical data flow processing sort of a program that's responding to user input and therefore going and fetching different data depending on what the user wants, and then mashing it up in a way that depends on the data that came through, and bringing in different operations and a couple of pieces of business logic, and it's hooking all those together, what are the number of paths through that system? A lot, right? Combinatorial complexity bites us, right? So what we've just said is that we've got a system which I've verified all the components, and I'd rather not redo all of that execution every time, because that would be expensive and useless. But there's a lot of complexity, and that complexity lies in figuring out when to do what. That's the semicolon operator. Right? So I can take exactly the same technique that I just did here and use it to test that. And here's a place where I can use any of the variations. It might be convenient to do the dispatch between things by a function call with some logging going on and write an approval test that traps around that. Right? It might be convenient to do some event pipeline the way that I did. And especially if you switch from an event pipeline that's just a delegation to another common one is an event pipeline that are a sequence of operations with a filter on each one that you put in a loop. Hey, look, that sounds like a rule system. Right? And then you could track out what that does in the sequence of operations there. Right? So a tremendous number of patterns can actually be reduced to replace your semicolons with some connective tissue that you can inspect. And then once you have that, inspect it. So I highly recommend looking at this, even if you're not doing something to async, because very commonly you're looking at something where what really matters is the connective tissue between two bits. And you need to make sure that you know what that is and get it under control. And this is actually a general technique that will do that. First, you make it into a template method. You've got good, clean bits, and you test each one. And then you lift those from code to data using promises or events or method calls or log statements. And then you verify it. Okay. So thank you. I've covered through the stuff that I'm interested in covering for. And I can take any questions that have arrived. No, I can't. All right. Then thank you very much.